Hi, this is Miss Conley.
And Miss Andrews.
And we are going to solve a system of equations using the elimination method. Alright, so we have our two equations here, 7x plus 2y equals negative 5, and 3x minus 5y equals negative 49. Okay, you notice right away that if we look at our coefficients, we have a 7 and a 3 for the x, and 7 is definitely not a multiple of 3, so that's not going to be too easy to eliminate. We have a 2y and a negative 5y, and 5 is also not a multiple of 2, so that's not going to be easy to eliminate either, but we want to eliminate the y's for two reasons. We have a positive and a negative, so that's going to be easy when we add those together to get 0. And also, if you look at the least common multiple of 2 and 5, that's 10, which is much smaller than the least common multiple of 7 and 3, which is 21. Okay, so we're going to choose to eliminate the y's. So in order to do that, we want to make the coefficient of our y variables 10 in both equations. Well, 10 in the top equation and negative 10 in the bottom equation. So we want to multiply the top equation by 5, the entire equation, and we want to multiply the bottom equation by 2.
So when we go through and do that, we want to make sure that we distribute that 5 to each piece inside the equation. So we end up with 35x plus 10y equals negative 25. So the 5 goes to all three pieces. And then in the second row, we have 6x minus 10y equals negative 98. And so we have our two y's all set up to be eliminated, the positive 10 and negative 10 coefficients. So then we can add the other pieces of our equations. So we have 41x equals negative 123. And we want to divide both sides by 41. And we get x equals negative 3.
Okay, so now we need to find the y value. So we can pick either equation, the top equation or the bottom equation, and substitute our solution in for the x. So let's use the top equation. I'm going to rewrite that over here. We have 7x plus 2y equals negative 5. But we know now that x is negative 3, so we're going to substitute that in for x. Okay, so now we just need to solve for y. 7 times negative 3 is negative 21, plus 2y equals negative 5. So we add 21 to both sides. So we get that 2y is equal to 16. Divide by 2 on both sides. So y is equal to 8. Now to check our solution, we would take negative 3 and 8, substitute them into both equations, and make sure that you get true statements. The last thing we're going to do is write our solution as an ordered pair with the x-coordinate first, which is negative 3, and then the y-coordinate, which is 8. And we write it as an ordered pair because this represents the point where the two lines intersect.